All right, advanced math A, here we go. We got lesson 8.1.1, investigating y equals b to the x power. So the most basic form of an exponential equation is where we got y equals b to the x. And we've called it in previous units that b value, the multiplier, because remember an exponential function, we're multiplying to get to the next number. These were like the sequences that we did that were geometric sequences. And so the geometric sequences we were multiplying or we were dividing to get to the next number. So that's what we're doing here. What we're going to do is we're going to graph each of these functions, y equals 2 to the x, y equals 3 to the x, and y equals 5 to the x. We're going to go ahead and graph them in Desmos, and we're going to try to get a feel for what does the 2, the 3, and the 5 do to that actual graph of that function. So let's go ahead and take a look at this. So here I've got Desmos. So here's my first one in red. This is y equals 2 to the x power. Now if I did 3 to the x, here's the graph of that. They look similar. They're both curves. But it looks like the blue one gets a little bit steeper. So that's 3 to the x. Let's do, the next one's supposed to be 5 to the x, not 4. Let's change that. All right, so let's do 5 to the x next. So here's my green one that's 5 to the x. So we've got all these different functions here. They're all a curve, but we see different growth patterns. And if you remember, we know why these growth patterns are different. They're different because they're being multiplied by a different number. The red one is being multiplied by 2 each time. The blue one's being multiplied by 3 each time. The green one's being multiplied by 5 each time. So we get curves with all of them, but there are different steepnesses to each of these curves that we have here. Okay, so on your paper, we're just going to quickly sketch what that looks like so that we have a reminder of what everything looked like here. So on your paper, go ahead and sketch it. I'm going to sketch it on mine. All right, so there I've got mine sketched out, and our first question is, do they have anything in common? And yeah, they do have something in common. Number one, they all increase. Now they increase at different amounts, but they're all increasing. From left to right, the y values are increasing. The other thing that they have in common is they all pass through the point 0, 1 right there. So they all have the same y-intercept. So they have the y-intercept of 0, 1. And then what we also have is all three of them look like over here they have an asymptote, which means they get closer and closer to the x-axis but never make it there. So it looks like they have the same asymptote. So they got some things in common. They're different, but they have some things in common. They're all increasing, y-intercept 0, 1, and they have the same asymptote because they're getting closer and closer to the x-axis over here. Okay, so what does the multiplier do to the graph? Okay, so the multiplier, the 2, the 3, and the 5, change the steepness of the graph. So they're all going to change how steep the curve is. So if we've got a bigger number as our multiplier, the graph is steeper, the curve is steeper. The smaller multipliers have a less steep graph on them. Let's go to 8-2. So on this one, we looked at it and all of the b values had a b value that was greater than 1. So we're going to ask ourselves a question, what happens if the b value is less than 1? All right, so we're going to use the E tool on your online textbook to take a look at that. So let me pull that up here. All right, so here's the E tool, and we can see that it's already set for y equals b to the x, and this is what's called a slider. And it says that right now b is 2. So that would be that first graph that we did in red on the previous one. And if I moved it up to the b value was 3, okay, that's the second graph. And then we also did the b value of 5. So there's the third graph. And we can see here that each time that I move that slider, the curve got steeper. So let's go back to 2. So we can see there that it got less steep as we went down to 2. All right, and the question for this one was, what happens when the b value is less than 1? Okay, so let's go down. Okay, see, it's getting less steep as I go. So b is still above 1. There it's at 1.1. There's at 1. And then look what happens when it's less than 1. Right now this is 0.8, 0.7, 0.6, 0.54, 0.4, 0.3, 0.2, 0.1. Okay, so in the opposite direction, what we see now is that this is no longer an increasing function. The function decreasing here. See, it's going downhill. And the smaller it gets, the steeper it gets. So it's like the opposite of the last time. The bigger the number got, the steeper it was in the other direction. So if we go over here, here's a b value of 8, and it's super steep. Then we go back the other direction. You see it's getting less steep, gets to 1, it's flat. And then when we go to a number smaller than 1, the farther away I get from 1, the steeper the graph gets. Okay, so let's write down what we found out about that. Okay, so we learned that when the b value was greater than 1, that it was an increasing function. Just like all these three. All of these, the b value is bigger than 1, and it makes an increasing function. Okay, and we saw when it was bigger, when the b value was bigger, it was steeper. But then when the b value was less than 1, then it became a decreasing function. And we saw as it got closer to 0, it was steeper. So if you've got greater than 1, it's going to be a function that increases like this. If you've got less than 1, it's going to be a decreasing function that looks like this instead. All right, next section. Okay, so we've got the graph of a function y equals 1/2 to the x power. This is less than 1, so our b value is less than 1, so that's why this is decreasing going this way. Okay, so we're going to describe what happens to y as x gets bigger. Well, each time that x increases by 1, so here I've got the point 0, 1, and then if I move over this direction, increasing x by 1, now I've got a y value of 1/2. If I go back the other way, it looks like it doubles going backwards. So what we can see here is that as x increases by 1, the y value is halved. Does this graph have a y-intercept? Well, we're cutting it in half. So if I got 1 here, I cut it in half, and I've got 1/2. And I cut that in half, I got 1/4. If I cut that in half, I get 1/8. If I cut that in half, I get 1/16, then 1/32, then 1/64, than 1/128th. So what's going to happen is, are we going to cross the x-axis? And the answer is no, because I'm going to keep on cutting it in half, which means I can never actually make it to 0, because I'm always going to get closer and closer by half, but never actually make it to 0. So we don't have an x-intercept. Because taking half of the previous number will never get us to 0. So the y value can never get down to 0. And remember, with our x-intercepts, our y value is always going to be 0. So there we go. We don't have an x-intercept. So that brings up our methods and meaning section. This is in your book. This one is about asymptotes. And it states that you get deeper into asymptotes, especially when you get into calculus and other things like that. But for us, we can see that we've had our first brush with asymptotes. We had mentioned it earlier. So asymptotes that we're going to be looking for are the horizontal asymptotes and vertical asymptotes. So a horizontal asymptote would be one that's flat like this, side to side. That previous problem we just had a horizontal asymptote. But asymptotes can also be vertical. So we can have vertical asymptotes. We can even have asymptotes that are curves or diagonal lines. And you'll see that as you get into more advanced math, that your asymptotes also get advanced as you go along as well. So the asymptotes are lines that your functions will approach but never actually make it to. So we can see here that we are approaching the x-axis, but we're never going to make it there because I'm always cutting it in half. So when I cut something in half, I can't actually make it to the end. I can't get to 0. Okay, so what type of asymptote are we looking at here? Well, we are approaching the x-axis, which would be a horizontal asymptote. And what's the equation of that asymptote? The equation is y equals 0. That is the equation of this line. Okay, so what's the y value? The y value is 0. The x values change, but the y value is always 0 along this line. So the equation of that asymptote is y equals 0. All right, let's go to our next page. All right, so if you're in class in groups, you're going to graph and describe the characteristics of these graphs right here. So what I want you to look at is what kind of shape do they have? What kind of intercepts do they have? What's your domain? What's your range? What's the asymptote? And what's happening to the y as the x increases? Okay, so I'm just going to do it for you since we're not in a group right now. So I'm going to plug in my first one. You don't have to go too far on this one. So there's my x and my y axis. I should have made it a little bit farther in the other direction, but it doesn't matter. So if I plug in 0 here, I get 1. So there's a point. Now this says that I'm dividing by 3. So on the next step, I should divide by 3 and get 1/3. Then I should divide that by 3 and get 1/9. And then divide that by 3 and get 1/27th, and then 1/81st. So we're getting really close to that line. Now going backwards, instead of dividing by 3, I'd multiply by 3. So this is at 1, so this point would be at 3 over here. And then this point, 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, so 9, divide by 3, 3. Divide by 3, 1. Divide by 3, 1/3. And so on and so forth. So there is our exponential function. We're going to get really close to this line right there. So what's its shape? Well, it's a curve. What are the intercepts? Well, it has a y-intercept, and the y-intercept is at 0, 1. What's the domain? Well, it's going to go this way forever, and it's going to go this way forever. So side to side, it goes forever. So the domain is going to be all real numbers. I can keep on plugging in any x that I want. Remember, our x's are a domain. So I can put 1,000 into here. I can put 2,000 into here. I can put negative 5,000 in there. I can keep on plugging in those values. There is nothing stopping me from plugging in any x value that I want. My range for this one is limited. This one, the y values, they're going to go forever up, right? So I can get bigger and bigger going up. But going down, see how this curve is flattening out over here? Because we're never going to get to y equals 0. So we're going to say that that has to be y is greater than 0. Because all of our y values never come down to the negative portion and they never get to 0. What's the asymptote? The asymptote is the x-axis, so that's y equals 0. What's happening to y as x increases? So as x increases by 1, y is being divided by 3, or multiplied by 1/3. All right, so looking at the other one. Okay, if we plug in 0 for this one, I get 0 right there. And then what we're going to do is we're going to multiply by 1.2. So if I go this way, 1 times 1.2 to the first power is 1.2. So I'm going to go 1.2, going to call it right there. And then I'm going to multiply that by 1.2. So 1.2 times 1.2 is 1.44. So 1.44, that's almost at that point there. Then I'm going to multiply by 1.2. And I get 1.728. So 1.728, probably right about there somewhere. This was too high, but there we go. Times 1.2 again. 2.07. So it's about right there-ish. Next one, times 1.2. Oops, 2.07. All right, it's 2.4. Sorry, I messed up when typing it in. Times 1.2 again. It's almost to 3. Times 1.2 again. It's at 3.5. A little bit more than that. Times 1.2 again. 4.3. 1, 2, 3, 4.3. And now we finally see that the curve is taking off here. See, it took a while, but we kind of finally see the curve. And if I go backwards, I divide by 1.2. And I get 0.8 going backwards. So this curve is not as steep, but it's definitely a curve. Okay, so we see that that's a curve. We can see that the y-intercept is at 0, 1. We can see the domain is all real numbers. We can see that our range is the same as this one over here. The range is going to be y is greater than 0. We can see our asymptote is going to be y is greater than 0. No, y is equal to 0. I don't know why I did that. I was looking right there. It's supposed to be looking right there. And we can see that as x increases by 1, the y value is multiplied by 1.2. All right, exponential functions such as y equals b to the x are defined only for b greater than 0. Okay, and why can we not have negative b values? Let's go back to Desmos real quick, to that E tool that we did. So over here we can see our graph. Everything's great, flip-flopping back and forth. Now watch what happens when I go to negative. The graph disappears. Something happens on this graph and it disappears when I get a negative over here. And that's because our graph is not continuous anymore when we go negative. You have to think of it like this. If I have, let's say, -2, and I take that to the x power. So I take -2 to the x power. If I take, let me move this so you can see. So if I take -2 to the x power, if I plug in 1, so I plug in 1, -2 to the first power is -2. But if I plug in 2, -2 times -2 is +4. If I plug in 3, -2 times -2 times -2, that's -8. If I plug in 4, I get 16. See what's happening? This is jumping all over the place. I've got negatives and then it's positive. Then it's negative, then it's positive. It's jumping all over the place. It's not going to be a nice little graph like this. You're going to have some points above and then some points below. You're going to actually get two separate curves going on there. So since we have a negative here, when we take it to a power, well, sometimes that's going to be positive, sometimes it's going to be negative. It's not going to make an exponential curve like this. So that's not going to make an exponential function. If you graph that, it's going to be all over the place. It would look something like this. You'd have some points up here, then you'd have some points down there while you're doing it. And it wouldn't be a continuous graph. Like you can't just connect these and make it do something like that. That's not working. So our b values have to be bigger than 0. So you can't go down to 0. Now let's think of other graphs. What if we've got y is equal to 1? Well, if I did an x value and a y value chart for that one, if I plug in 1, 1 to the first is 1. If I plug in 2, 1 to the second is 1. If I plug in 3, 1 to the third is 1. I'm getting 1 every single time, and the graph of that is a horizontal line going through 1. Because here's 1, 1, here's 2, 1, here's 3, 1. So when we have y is equal to 1 to the x power, we get a horizontal line, and that's not an exponential graph. Now what about y is equal to 0 to the x power? So if I plug in numbers for that one, I get something similar. Like if I plug in 1, 0 to the 1 power is still 0. If I plug in 2, 0 to the second power is still 0. If I plug in 3, 0 to the third power is still 0. And it looks like this is going to be a horizontal line that's sitting on top of the x-axis, but what we're going to see is it can't be negative. What we have to remember is what happens to negative exponents. Negative means that you do the reciprocal. So if I've got 0 as my multiplier, the reciprocal would put 0 in the denominator, and we're not allowed to have 0 in the denominator. So this one only works on the positive numbers, and then it makes undefined numbers over here on this side. So 1 as a base, as a b value, and 0 in a b value doesn't work. So when we're looking at exponential functions, we're really looking for b values. B values have to be greater than 0. And then they cannot, I should write that the other way. B has to be greater than 0, and B cannot equal 1. So basically, it has to be a positive number, can't be 0, and 1 doesn't work because that just makes a horizontal line. So if we want exponential functions, we have to have a number that's greater than 0 and not equal to 1. All right, that's all I got for you. Math hard. I will see you later. Bye-bye.